Welcome to our 4-tape video series on automatic fire sprinkler systems. In Tape 1, we will cover the basics of fire sprinkler systems, what a fire sprinkler system is, where it's used, and why. Tape 2 is devoted to the subject of hazard classification, or those factors that determine how the fire sprinkler system will be designed and applied. Tape 3 covers the various types of water supplies, including an explanation of how water supplies are evaluated and calculated for a fire sprinkler system. Finally, in Tape 4, we will discuss the importance of maintaining these vital systems. According to the National Fire Protection Association and NFPA Standard 13, a fire sprinkler system is defined as an integrated system of underground and overhead piping designed in accordance with fire protection engineering standards. The installation includes one or more automatic water supplies. The portion of the sprinkler system above ground is a network of specially sized or hydraulically designed piping. It is installed in a building structure or area and is generally overhead. Sprinklers are attached to this piping network in a systematic pattern. A valve controls each system riser and is located in the base of the system riser or in the riser's supply piping. Each sprinkler system riser also includes a device for actuating an alarm when the system is in operation. The system is activated by heat from a fire and discharges water over the fire area. There are 4 basic types of automatic sprinkler systems: wet pipe system, dry pipe system, pre-action system, deluge system. A wet pipe sprinkler system is one in which water is constantly present at each sprinkler, so that when it opens, water discharges immediately. This is the most common type of fire sprinkler system because it is the simplest and most dependable. Contrary to a popular misconception, each sprinkler operates individually. They don't all flow at once. For an office fire, typically less than 5 sprinklers will be necessary to control or suppress the fire. Dry pipe systems are designed for applications that will be subjected to freezing temperatures. In a dry pipe system, air, or in some instances nitrogen, is contained in the system piping under pressure. When a sprinkler operates, the gas is released from the piping. This action causes the water pressure to open a valve known as a dry pipe valve. Water then flows into the system piping and is discharged from any of the sprinklers that have been actuated. If the area subject to freezing is limited, an antifreeze system may be utilized. Antifreeze systems consist of wet pipe systems filled with antifreeze. A pre-action system uses a supplementary detection system containing heat detectors or smoke detectors. When activated, these detectors cause a valve to open, which in turn admits water into the system piping. In a pre-action system, closed sprinklers are installed on the system piping, which is then filled with a small amount of air pressure. The air pressure is provided only for supervisory purposes to detect leaks in the piping. At the time of a fire, the detection system activates to open the pre-action valve. This allows water to flow into the piping. Water will not be discharged from the piping until the sprinklers have actuated. Pre-action systems are used where there is a concern for premature discharge of water, such as computer rooms and museums. They are also recommended for areas that are subject to freezing, where a delay in water discharge, such as in a dry pipe system, must be avoided. Pre-action systems can also be installed with a double interlock. In this arrangement, the detection system must operate, and the air or gas pressure within the piping must release before water will flow into the piping. A deluge system is similar to a pre-action system, except that the sprinklers are open. It employs the same valve as a pre-action system and has a supplementary detection system. When the valve opens, water flows into the piping and discharges from all the sprinklers. Deluge systems are used in applications where rapidly developing fires, such as those from flammable liquids, are expected. There are three basic piping arrangements for automatic fire sprinkler systems: a tree system, a gridded system, or a looped system. A tree system is the most common type of piping arrangement and can be used with any type of fire sprinkler system. In a tree system, the lines on which the sprinklers are installed, called the branch lines, are dead-ended. A gridded system has parallel piping supplying the branch lines called cross mains. These cross mains are connected to multiple branch lines in a grid arrangement. The gridded system layout can be used on any fire sprinkler system except dry pipe systems. In a looped system, multiple cross mains are tied together so that there is more than one water flow path to a sprinkler, but the branch lines are not tied together. This type of piping arrangement is acceptable for any type of fire sprinkler system. There are also several types of sprinklers, each one designed to adapt to specific installation requirements. The spray sprinkler is the most typical sprinkler. It is the one upon which the requirements of the NFPA 13 are based. This type of sprinkler distributes 90% or more of the water discharge downward. A conventional or old-style sprinkler has similar operating characteristics and construction to a spray sprinkler, but only directs 40 to 60% of the water discharge downward. An extended coverage sprinkler is specially listed to protect a larger area than the typical sprinkler. The typical sprinkler covers 225 square feet or 15 feet by 15 feet for light hazard occupancies. So anything beyond these parameters is considered extended coverage. A quick response sprinkler system is one that meets certain response characteristics for responding to fires more quickly than the typical sprinkler. A recessed sprinkler is installed so that a portion or all of the sprinkler body is mounted in a housing recessed into the ceiling. In this arrangement, the sprinkler is installed in the pendant position. A pendant sprinkler directs the water spray downward towards the sprinkler deflector, while an upright sprinkler directs the water spray upward towards the sprinkler deflector, effectively distributing the water stream. A flush sprinkler positions the majority of the sprinkler above the lower plane of the ceiling. A concealed sprinkler is a recessed sprinkler which has a cover plate installed so that it is generally at the same plane as the ceiling. In a fire situation, the cover plate falls off before the sprinklers operate. A sidewall sprinkler is intended to be installed along a wall and has a special deflector designed to discharge most of the water outward from the wall. There are also other types of special application sprinklers, such as attic sprinklers, early suppression fast response or ESFR sprinklers, large drop sprinklers, and extra large orifice or ELO sprinklers. Most of the sprinklers we've just described are available in different temperature ratings to accommodate the ambient temperatures in which they may be located. Sprinklers are also available in various types of coatings or platings for aesthetic reasons or atmospheric protection. There are numerous factors that should be considered when selecting a suitable sprinkler system: the type of sprinkler, the sprinkler's material and coating if necessary, and the piping configuration. The services of a fire protection engineer who is experienced in the design of fire sprinkler systems can assure that all factors are considered and make sure you receive a cost-effective, reliable system. A fire sprinkler system is intended to have a number of important characteristics. 1. In the event of a fire, the system is automatic. In other words, it will function without human intervention. 2. The system is thermally activated. In order to achieve automatic activation at a reasonable fire size, that is not too large or too small, sprinklers are activated by heat, the characteristic present in all unfriendly fires. 3. The system is designed to distribute water to the fire. Water is the plentiful and inexpensive extinguishing agent that can be distributed in a defined manner according to the design of the sprinkler system. 4. The objective of the system is to control fire. In this context, control is achieved when the temperature of the area surrounding the fire is reduced enough to slow the fire down and keep it from spreading rapidly. Actual extinguishment of the fire can then be achieved manually. Of course, in the best-case scenario, the sprinkler system may also extinguish the fire. All of these characteristics are intended to protect people and property from unfriendly fires. Fire sprinkler systems are designed to protect 4 basic classifications of hazards. We will review this topic in greater detail in Tape 2. For now, here are the 4 hazard classifications. Light hazard. This category includes applications where the relative combustible load and potential rate of combustion is less. Office buildings, public facilities such as restaurant seating areas, and residential dwellings are examples of light hazard occupancies. Ordinary hazard group 1 and ordinary hazard group 2. Automobile parking garages and commercial kitchens are typical ordinary hazard group 1 occupancies. Retail stores, repair garages, and light manufacturing are examples of ordinary hazard group 2. Extra hazard group 1 and extra hazard group 2. Extra hazard occupancies are characterized by greater quantities and combustibility of contents, such as flammable and combustible liquids, combustible dust, and similar materials. The applications of a fire sprinkler system are affected by the occupancy of the building or facility it is protecting. For example, the system may be intended to merely meet the code requirement because the code specifies protection by automatic sprinklers. Alternatively, the fire sprinkler system might also be intended to achieve construction credit. In this case, the sprinkler system is provided in order to qualify for credits which the code permits. These credits might include a reduction in the fire resistance of the structure's materials from, say, 3 hours to 2 hours, or the elimination of the fire resistance rating for corridors. The issue here is that the sprinkler system may not be required unless the owner is seeking the construction credits, specifically allowed by the code. A sprinkler system might also be provided as part of establishing an equivalency or an alternative to a specific code requirement. For example, installing a non-required sprinkler system or enhancing a code-required system may be part of a performance-based design approach that will provide the desired level of overall protection. Examples could be to allow more open and interconnected levels in an atrium when an enhanced sprinkler system is provided, or allowing exposed steel structural elements to be protected by automatic sprinklers in lieu of fireproofing. A fire protection engineer experienced in the development of equivalencies and the design of fire protection systems can provide cost-effective alternatives that meet the intent of the codes as well as the design and operational goals of the protected facility. A sprinkler system can also be used to achieve a fire insurance premium credit. This is more common for industrial occupancies. It is generally not a factor for commercial properties because most fire insurance premiums for lower risk facilities are already low enough that little, if any, credit for automatic sprinkler protection is granted by the insurance company. The insurance carrier or broker should be consulted regarding the potential impact on premiums. As we discussed previously, the common objective for providing commercial facilities with automatic sprinkler protection is to achieve enhanced life safety and property protection. According to NFPA, automatic sprinklers are particularly effective for life safety because they warn of the existence of fire and at the same time apply water to the burning area. With sprinklers, there are seldom problems of access to the seat of the fire or of interference with visibility for firefighting due to smoke. While the downward force of the water discharged from the sprinklers may lower the smoke level in a room where a fire is burning, the sprinklers also serve to cool the smoke and make it possible for persons not close to the actual fire to remain in the building much longer than they could if the facility was without sprinklers. NFPA has no record of a multiple death fire, a fire which kills 2 or more people in a completely sprinklered building where the system was operating properly. The only exceptions have been where an explosion or a flash fire killed industrial fire brigade members or employees during fire suppression operations. Automatic fire sprinkler systems are commonly used in a number of special situations where they protect individual hazards. Flammable liquid storage and handling areas are common examples. Sprinklers can also be used to protect building construction. Some codes, for example, allow a reduction in the roof fire resistance rating by 1 hour for buildings protected by automatic sprinklers. NFPA recognizes that fire protection of roof steel is not required for buildings having rack storage with sprinkler systems installed in accordance with NFPA 231C. NFPA accepts automatic sprinkler protection as a means to provide fire protection of steel building columns for certain storage arrangements. For atrium areas, glass protected by automatic sprinklers is permitted in lieu of 1-hour fire-rated partitions for buildings protected by automatic sprinklers. Recently, a special application window sprinkler was tested and listed, which allows certain size glass to have a 2-hour fire resistance rating. This arrangement does not rely on automatic sprinkler protection for the building. Automatic sprinklers have also been used to protect wall openings from both interior and exterior fire exposure. Automatic fire sprinklers offer a number of benefits for the building owner as well as to the community at large. The owner or occupant can expect the automatic sprinkler system to minimize damage from fire. This should reduce business interruption, thereby allowing operations to resume promptly. Often, the sprinkler system detects and extinguishes the fire so quickly that there are negligible effects on business operations. For the building's occupants, the issue is life safety. Statistics indicate that it is unlikely that people will be injured or killed from fire in a building that is protected by sprinklers. Automatic sprinkler systems will also offer more building design flexibility. The owner will have greater choices in interior finishes and construction materials. Fewer or smaller exits may be required. Fire insurance costs will generally be lower. This affects both the building construction expense and the cost of occupancy. Automatic sprinkler systems pay dividends to the community as well. Sprinkler buildings place a lower demand on the fire protection resources of the community. The fire record shows that sprinkler systems are very effective in keeping fires small, reducing the number of firefighters needed to extinguish the fire, and using less water than if the building were not protected by sprinklers. The possibility of fire spread to nearby structures should a fire occur in the sprinklered building is unlikely. There are some disadvantages inherent with automatic fire sprinkler systems, although these drawbacks are all manageable and the benefits far outweigh the disadvantages. Partition layout in a building may affect sprinkler layout, so if the partitions are changed frequently, the automatic sprinkler system may need to be altered or the height of the partitions modified so as to avoid sprinkler obstruction. There is also an increased potential for water damage to buildings protected by automatic sprinklers. According to NFPA, accidental discharge of water from an automatic sprinkler system or other parts of a fire protection water system due to defects in sprinklers, water control valves, piping, or associated equipment is very rare. NFPA estimates that 1 in 16 million installed sprinklers will fail and allow water discharge, and that 1 in 2.5 million installed systems will fault and permit water discharge. In most cases, such failures are the result of poor quality control during initial installation or of lack of maintenance. In Tape 2, we'll examine the factors that should be considered prior to selecting an automatic fire sprinkler system. We'll also discuss hazard classification and how it affects system design.